Hello class. Okay, this is a simple primer on calculus. Calculus. Now you might think, oh gee, I've always heard about calculus, it's so terrible, or maybe you had it long ago and you've sort of forgotten. But basically, if you've ever had a course in even the most rudimentary rules of algebra, you've learned a little calculus. Let me show you. Do you remember, probably way back in middle school someplace, you would get graphs like this and they would ask you to find the equation of the line, and there was a form you used, was y is equal to mx plus b. Remember those days? And so by looking at that graph, you can see that the slope of that line was 2, so it would be 2 times x plus the y-intercept is this little symbol b, and the y-intercept was 50. So the slope, or the equation of that line, would be y is equal to 2x plus 50. And then if they ask you later, well, what would it look like if it was y is equal to 2x plus 20? Then it would have exactly the same slope, but it would hit down here at 20, and it would look like that. Or, what if they said, what if you had an equation that was something like y is equal to minus 2x, let's see, plus 50. What would that look like? Well, it would hit at 50, so it would hit here, but now its slope is minus 2 instead of positive 2, and it would look something like that. Remember all those exercises that you did back in middle school? In each case, you were finding the slope of the line. And in calculus, the word we use for slope is a derivative. A derivative of something, hope I spelled it right, the derivative of something is just an equation that describes the slope of the original equation. So in these three equations that I've given here, or these two equations, the slope is, in this case, 2, so its derivative, the derivative of this equation is 2. And in this case, the slope is minus 2, so its derivative is minus 2. Now the reason this is important is because a lot of functions aren't linear. They're nonlinear. So for example, suppose you had an equation like this. Y is equal to x squared. Well, when x is 0, y would be 0, because 0 squared is 0. When x is 1, y would be 1, because 1 squared is 1. But now when x is 2, y would be 4, alright, because 2 squared is 4. And when x is 3, y would be 9. So I hope you can see that this function is nonlinear. It gets steeper and steeper and steeper as x gets larger and larger. And even though I didn't draw this side of it over here, you could see that when x is minus 1, minus 1 squared is 1, that would be here. When x is minus 2, it would be minus 4, minus 9, and so forth. So for these nonlinear functions, the idea of what is the slope of that function requires you to specify a particular place. So we could ask, what is the slope here? Or what is the slope here? Or what is the slope here, or over here someplace, and so forth. So unlike a linear function where the slope is the same all the time, in a nonlinear function the slope is different at every place on the function. And that's why derivatives are so important, because derivatives will give you an expression that describes the slope of the original function wherever you are. So, what is the rule? Well, here is the rule. Let's imagine that you had some function, let's just call it f of x is equal to ax to the b. F of x is ax to the b. And I ask you to find the derivative of that thing, and the way we would notate that is like this: f prime of x, which is the notation for the derivative, and here is the rule. Step 1, you write down the exponent. So the exponent was b, I write it down. So step 1, you write down the exponent. Step 2, you copy down everything that was in the original expression. So that would be ax to the b. So that's step 2. You copy down everything that was there. In step 3, you subtract 1 from the exponent. Well, the exponent was b, so we take away 1. And there you go. That's the derivative. It's really very simple. Step 1, you write down the exponent. Step 2, you copy down everything that was there. Step 3, you subtract 1 from the exponent. So let's try a few so you'll see how simple it is. Imagine you had f of x is equal to 2x cubed. Okay? And I ask you to find the derivative of that thing. So step 1, you write down the exponent, which is 3. Step 2, you copy down everything that's there. Step 3, you subtract 1 from the exponent. And there you go. That's all the calculus you need. Of course, the algebra is a little bit messy, so we need to clean this thing up. So 3 times 2 is 6, and x to the 3 minus 1 would be x squared. Okay? So let's just call that g of x. So g of x is 6x squared. I'm just making that up. And suppose I ask you, okay, find the derivative of g of x, which you would notate like that. Alright, now you try it. Stop this video when you try it. The answer would be, step 1, you write down the exponent. Step 2, you copy down everything that's there. Step 3, you subtract 1 from the exponent. And then, of course, step 4 is you kind of clean it up, which isn't really calculus, it's just algebra. So step 4 would be, it is 2 times 6 is 12. X to the 2 minus 1 is 12x to the 1, which we normally write as 12x. So let's call that A, B, C, D, F, G, let's call that h of x. Alright, let's try again. So suppose I gave you h of x was 12x, and I ask you to find the derivative of that thing. You would write it like that. Okay? So here we go. Step 1, you write down the exponent. You don't really see an exponent here, but what you have to remember is there's a little invisible 1 sitting over here. It's really 12x to the 1, right? So step 1, you write down the exponent, which is 1. Step 2, you copy down everything that's there, 12x to the 1, right? Step 3, you subtract 1 from the exponent. And then, of course, step 4, which is really just the algebra, you clean that thing up. Alright, so 1 times 12 is 12 times x to the 1 minus 1 would be x to the 0. Now, this is an obscure rule in algebra that you've probably forgotten if you haven't used it very much. But what does it mean to write x to the 0? Many of you think that any number raised to the 0 power is 0, but that's not true. Take out your calculator and put in any bizarre number you want and raise it to the 0 power and see what you get. You will find that it is 12 times x to the 0 is the same as 1. Any number raised to the 0 power is 1, so it is 12. So this leads to kind of a shortcut that some students use. You don't really need it. You can just use the rule that I've given you. The rule I've given you is this thing up here, right? But some students use a kind of a shortcut rule that goes like this. If you have a really simple function like h of x is equal to 12x, they'll use this shortcut rule that says the derivative of that is just the coefficient on x, which it was 12, right? But if you applied the rules, I hope you can see that it was 1 times 12 times x to the 0, which is just 12. Okay, now let's do it one more time. Let's see, A, B, C, D, E, F, G, H. Let's say you had I to the x. So you had some function I to the x is equal to the number 12, just by itself. I to the x equals 12. And I ask you to find the derivative of that thing. Alright, step 1, you write down the exponent. Well, in this case, there's no variable here, so you're kind of stuck like, what's the exponent? And this is what you have to remember. There's really a little invisible x to the 0 sitting over here, right? Because anything to the 0 power is 0. So step 1, you write down the exponent, which is 0. Step 2, you copy down everything that's there. Step 3, you subtract 1 from the exponent. And step 4, which is the algebra, you just clean that up. And now in this case, here's a 0 times this thing in here. 0 times anything is 0, which leads to the second shortcut that many of you have probably learned in a calculus class long ago, and that is if you take the derivative of a number all by itself without a variable attached to it, the derivative of just a regular number is 0. But I hope you can see that the rule I've given you applies all the time. Now, let me show you what you were doing back in middle school. Imagine you had this equation, x is equal to minus 2x plus 50, and somebody asked you to take the derivative of that thing. What would it be? You would do it like this. Y prime is the notation you would use for derivative. And now you have two terms. You have this first term, minus 2x, and then you got the second term over here, plus 50. So let's take the derivative of this thing. So we're going to have to do it twice, once for each term. So what is the derivative of minus 2x? Well, I hope you can see that the derivative of minus 2x is just minus 2. Now I've done them so often that they just come second nature to me, but if you don't see how I got minus 2, you should go back to the rule I showed you, put in minus 2 and take its derivative by the rule, and see for yourself that its derivative is just the number minus 2. Alright, then let's bring down our sign. Now what's the derivative of this number 50? Well, I hope you can remember that the derivative of a number is just 0. So y prime is minus 2. Or to put another way, the slope of this line right here, the slope of this line is minus 2, which you already knew probably from the 8th grade, but now with calculus, you can take its derivative and you can see its slope is minus 2. Alright, so calculus is kind of silly for a linear function, but for nonlinear functions it's quite important. So let's go back to this one we did over here. So now we have this function y is equal to x squared, and I ask you to take its derivative. Alright, stop this video and make sure you can do it. But you should see that the derivative is 2x. Now what does that mean? It means that this expression right here, 2x, will give you the slope of the original function at any place you want to find it. So for example, suppose I ask you, what is the slope at this dot up here where x was 2 and y was 4? What is the slope there? Well, the slope is 2 times x, and x was 2, so 2 times 2 is 4. The slope right here is 4. So if you could put a tangent line on that and find its slope, you would find it is 4. By the way, what's the slope over here where x is 1? Its slope would be 2 times 1 is 2. So the slope right here is 2. The slope down here is 0, right? The slope over here, if you cared to do it, since this is minus 1, the slope over here would be 2 times minus 1, or minus 2. So can you see how these derivatives work? Now, the reason this is important in economics is because sometimes we have functions and we're trying to find like the maximum of a function or the profit place or something like that. So you might think about, maybe you saw in a principles class someplace a total cost curve and a total revenue curve. If you had a decent econ class, you would have seen something like this. And this is Q on this axis and dollars over here. And somebody would eventually ask you, where are profits maximized? Well, since profits are equal to total revenue minus total cost, profits are equal to total revenue minus total cost, what you're looking for is the place that is the greatest vertical distance between this revenue function and this cost function. And you need calculus to find that, because when you're at the greatest distance between them, it must be that the slopes of the two functions have to be the same. The slopes have to be the same, because if they're not the same, you could do better by moving one way or the other. For example, if this slope down here was a little bit flatter than that slope up there, you could do better by moving to the right. On the other hand, if this thing was a little bit steeper than that slope up there, you could do better by moving a little bit to the left. It's only where the slopes are exactly the same would your profits be maximized. And I hope you can see that the slope of the total revenue function would be its derivative, right? Because the derivative of something is a new expression that describes the slope of the original expression, and the slope of the total cost function would be its derivative. And so you can find the profit maximizing place by just setting those two slopes equal to each other and solving. So another place that the calculus is used is if you have like that fishing problem, right? The problem of the commons. And in that particular problem, you had a fishing effort function, which looks something like this, right? Fishing effort. And then you had a cost function that looked like this, right? Dollars on this axis. And you needed calculus to find the biologist solution, which is up here on the top. This is the biologist solution. So how would you find that? All right, now you think about it a second, and then I'll tell you. You would find it by noticing that when you're at the tip top of this thing, the slope of the value function must be 0. Slope equals 0. All right? And all you would do is take the equation for this line, find its derivative by that rule I gave you, and setting it equal to 0 because you're looking for the place where the slope is 0, and that would give it to you. Now, the last part of a problem like that is generally, well, what would people do if you had property rights? And if you had property rights, they would move over here, where this distance right here, which is their profit, that distance would be maximized. And just like in the case of profits for a regular firm that we did a moment ago, I hope you can see that this place would be where the slope of that value curve would be exactly equal to the slope of the cost curve. And to find that, you would need to take the derivatives of both of those curves and set them equal to each other and solve. Alright, so I hope that helps you. And if you're still stuck, I guess probably the best way to do would be to post something to a discussion board or maybe call me. I'm usually in the office in the afternoons. Okay, good luck.